Good day everyone, this is Lesson 1. In Lesson 1, we will study the nature of mathematics. What is mathematics? And how are you going to describe the things that you are going to study under mathematics? In this lesson, we will study the nature of mathematics, what is math, where are you going to use math, by just simply watching two video clips. One is Nature by Numbers and another about Fibonacci. So I would like you to watch them, and then I would like you to read a PDF file entitled Nature's Numbers by Ian Stewart. Just do the exercises that you find in exercise L-1. So I hope you will be able to appreciate why there is a need for you to study mathematics.
About 15 billion years ago, there were no stars in the sky. There wasn't even a sky. All that existed was the primordial fireball. Primordial fireball. Primordial
Then,
fireball.
Something happened. In a flash, everything suddenly expanded. This was how it all began. The first moment of existence. What we now call the Big Bang. Big Bang. Big Bang. Big Bang. Big Bang.
At the beginning of the 20th century, scientists believed that the universe had always existed, that matter energy was infinite. It had always been around. The model is called the steady state model because the model of the universe that it's been around forever basically doesn't change. The universe is steady state. But what happened in the last 100 years is that model has been blown away because of the evidence. Observations now suggest, as you all know, that the universe began some 12 to 15 billion years ago. The first evidence that the universe had a beginning is the expanding universe.
Researchers wanted to believe in a universe that always was and always will be, eternal. But galaxies flying away from each other meant that once, long ago, they were clumped together. It meant something started them moving. The universe had a beginning. Today, it's called the Big Bang Theory.
This was first discovered in 1929 by Edwin Hubble, and it's the first evidence that the universe had a beginning. The second evidence the universe had a beginning is the cosmic background radiation.
The discovery of the cosmic background radiation was a fatal blow to those who wanted to believe in an eternal universe. The Big Bang proponents had won.
Now, the final evidence for the origin of the universe is the relative abundance of light elements. It's very clear now that the universe had an origin, and scientists have become to accept this. In fact, the equations of general relativity that Einstein developed had an origin of the universe. When Einstein developed his equations of general relativity, they showed that there should be an expansion of the universe and an origin, and Einstein didn't like that. He added something called a cosmological constant, which he later realized was not there. When we saw that the universe was expanding, that there really was an origin, he threw out the cosmological constant. He said that that was the biggest mistake of his scientific career, was introducing that, was introducing that, was introducing that, was introducing that.
That there is a mathematically precise structure to the universe and everything in it. One everyday example of this precision can be found in the plants. Many plants, including elm trees, grow their leaves, twigs and branches placed exactly halfway around the stem from each other. Next in the series are plants like the beech tree, with leaves placed 1/3 of the way round the stem from the previous leaves. Third in the series are the plants like the oak, with leaves placed at every 2/5 of a turn. The holly plant is the next at 3/8, while the larch trees are the next at 5/13, and the sequence goes on and on. Notice the number sequence of these fractions: 1, 1, 2, 3, 5, 8, 13, and so on. Each number is the sum of the two numbers which came just before it in the sequence. This particular mathematical pattern is called the Fibonacci series.
Take, for example, the sunflower. The display of its florets are in perfect spirals of 55, 34, and 21. The sequence of Fibonacci. The sequence of Fibonacci. The sequence of Fibonacci. The sequence of Fibonacci. The fruitlets of the pineapple create the same spiral based on the sequence. The pine cone does the same. As currents move through the ocean and the tide rolls onto the shore, the waves that bring in the tide curve into a spiral that can be mathematically diagrammed onto a plot at the points 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Buds on trees, sand dollars, starfish, petals on flowers are formed with this exact same blueprint. This blueprint can be seen around us on a small scale every day, but the greatest example of all is directly above our heads. At an average of 100,000 light years across, even the spiral of the galaxies above us are formed with the exact design. This sequence, or blueprint, appears to be the trademark of a designer, a proof of a creator.
Also known as the golden mean, the divine proportion is a mathematical formulation exhibited in everything from the double helix of DNA.
The DNA molecule, the code for life, is made up of two intertwining spirals. We find the 0.618 ratio between the helix's width and cycle length.
To the form of the human body itself.
Do something like measure the distance from the floor to your navel, and then from your navel to your head. If you're well proportioned, the ratio should be 1 to 1.618, and that ratio is seen all over the beautiful body.
People started noticing it. Artists noticed it. The width of the in a beautiful face, for example.
Yeah.
Not in any face, but it had to be beautiful. If a face was beautiful, the width of the mouth was exactly 1.618 times the width of the nose.
Right.
If the face wasn't beautiful, that wasn't the case. Dentists, in their dental work, noticed that the upper front tooth was 1.618 times as wide as the next tooth over, the lateral incisor.
Oh.
So the central incisor was 1.618 times the width of the lateral incisor, the next tooth over.
Wonderful. Give me some more examples.
Your fingers, your fingers are each called phalanges, and each bone of the finger is called a phalanx. And the phalanx that's the closest to your knuckle here is 1.618 times the phalanx that's in the middle, and that's 1.618 times the length of the phalanx at the end, which is your fingernail. So that was kind of amazing. This number would come up over and over again.
Then we find the Fibonacci ratio in heart muscles, in bronchial tube branching, even in the electrical potential of neurons, and as Roger Penrose pointed out, even in the arrangement of the brain's microtubules.
As we scan our universe, from the tiny flower to the awe-inspiring galaxy, we see the fingerprint of God.
You see how, everything's falling in the same direction. So when everything, all these conclusions point to the same direction, that it's covered up and hidden,